Hello, future Boilermakers, and welcome to our YouTube live broadcast for the School of Engineering Technology in the Polytechnic Institute at Purdue University. My name is Ryne Kerchner. I'm the Associate Director of Recruitment here for the Polytechnic. So our broadcast tonight will feature several panelists from the Engineering Technology School who will give you some insight into the school, the experiences you can expect into our undergraduate programs, and how you'll be prepared to take on engineering careers when you graduate. I'll have our panelists introduce themselves here in a few minutes, but first a couple logistical things, so how you can interact with us in the broadcast. We have some topics prepared already and some questions for our panelists ready to go, but we also want to know what you want to know. So you can sign into your Google account and join the chat in the YouTube broadcast. So send in your questions through there. Myself and our technical director, John, will be responding to those questions, as well as pulling some of those questions to our panelists as well. We'll try to answer all of them as best as we can tonight. But we might get busy. So if you have any follow-up questions, please send us an email at techrecruit@purdue.edu, and we'll respond to you later on after that. So first, just want to say thank you for joining us tonight. Really appreciate your time and attention, and we hope we give you a lot of information about our School of Engineering Technology here. And with that, I'll have our panelists introduce themselves. So as I go through our list today, just share your name, obviously, your affiliation with the Polytechnic, maybe a little bit of what your experience has been, your classes that you teach, if that's your role, just to give our viewers a little bit of understanding who you are. So first of all, we'll start with Anne. And you're muted right now.
Oh, bummer.
There's always one that starts out this way.
No, it's okay. I'm an assistant professor in the School of Engineering Technology, and currently I teach a course in how power plants run and look at some environmental stuff with renewable energy. And I also teach fluid mechanics, which is basically looking at moving fluids from one point to another. Most of my students are seniors. I work really closely with a lot of them, trying to help them launch themselves into their future career. And we have a good time doing it. I just read all of my evaluations from mid-semester, and everyone's having a good time. So that's what counts.
That's always good to hear, some good feedback from yourself, right? Next up, April.
Thank you, Ryan. Hi, I'm April Cheung. I'm an assistant professor of practice, and I teach mostly second semester EET courses, and they are AC and power electronics and C programming in embedded digital systems. And my students are mainly EET, robotics, mechatronics students.
All right, great, thank you. Next up, Tamara.
Hi, my name is Tamara Groll. I am one of the academic advisors in the Polytechnic, so I don't teach any classes, but I help you choose the classes that you're going to take and make sure that you are always meeting degree requirements so that hopefully at the end of 4 years, you're graduating with a degree in the field that you have chosen. So we're always excited to work with our students.
All right, great, thank you. Next up, Emmani.
Hi, everyone. My name is Emmani Ellis. I am a student here, sophomore year, double majoring in mechatronics and robotics engineering technology. And I'm in like industrial robotics classes. April's actually my teacher right now for embedded digital systems. Miss Tamara Groll is actually my advisor. So close-knit community, but I'm a sophomore year.
All right, thanks, Emmani. Next up, Jason.
Okay, thank you, Ryan. Hello, everyone. My name is Jason Ostanek. I'm an assistant professor here in the School of Engineering Technology. I teach a senior level course on internal combustion engines, and I do research on lithium-ion battery systems. So I try to keep one foot on both sides of the fence in terms of which is going to win out, the internal combustion engines or the electric vehicles. I try to keep both of them covered. Thank you.
All right, excellent, thank you. Next up, Ken.
Good evening, everybody. I'm Ken Burbank. I'm actually the head of the School of Engineering Technology. I'm delighted to spend some time with everybody tonight. This is a quick point of fact here, if you want. The School of Engineering Technology has almost 75 faculty members. So it's a fairly big unit. And so we have a good time, and we're looking forward to having a good time when you're here. Thank you.
All right, thanks, Ken. And last but not least, Mark.
There we go. Hi, my name is Mark French. I'm a professor. I'm sorry, I got my cat here. Won't get off the back of the chair. So that's the cat. It's just easier this way. Sorry. My name is Mark French. I'm a professor in mechanical engineering technology. I teach classes in structural mechanics and some graduate classes, but I also teach a class on stringed instrument design and manufacturing. When I'm not professing, I help run the Purdue Guitar Lab and work on instrument design. Hang on a second. Anyway, so I'm working with some of the big guitar companies in the US right now on design improvements, and I'm writing my third guitar book.
So Mark, we got to know, what's your cat's name? Because we love the cameo right now.
Yeah, 13 years in engineering school. This is what it came down to. Her name is Angel, and the reason her name is Angel is when my daughter adopted her a long time ago. My daughter didn't want me calling her Angel, so she named the cat that. Figured I'd have to change my mind. So Angel's about, I don't know, we think she's 17 now. So she's kind of stubborn.
Wow, that's
Frankly.
impressive. Very nice. Well, glad to have her on board with us tonight. Really cool.
Okay.
I think at this point in this kind of virtual world we're mostly living in, we're all used to interruptions and cameos like our cats and
Okay.
other pets and children, whoever else might be there. So
All right, well,
well, thank you all for the introductions. Really appreciate it. Just to kind of start out, Ken, we'll start with you as the head of the school. I get a question a lot in recruitment, and so do my colleagues, and you all probably get this question a lot too, potentially, when you talk with students. But what's the difference between like an engineering program and engineering technology, like the educational approach? What would you say is that big difference in how we take things on here?
Thanks, Ryan. Yeah, we do get this question a lot. There's no doubt about it. One of the wonderful things about being here at Purdue is that we're national leaders and that we are intimately involved in this conversation across the United States and pretty much across the world. So one important thing to remember about this is that engineering is a profession. It's going to be your career. You're going to be an engineer coming out of one of our programs. And there are multiple educational paths to becoming an engineer. And one of the wonderful things about Purdue University is we got 4 colleges that produce engineers every year. Our College of Ag, our College of Science, our College of Engineering, and the Purdue Polytechnic Institute. Engineers come out of all of these schools. And so really one of the keys for you at this point is to know how you learn and how you like to learn. Because how you learn, especially engineering, will really drive where you're going to be the most successful here. And for us, and for most of the faculty here in the School of Engineering Technology, we love working in the labs with students. So almost every one of our classes has an associated lab. We spend hours a week working with students, typically in smaller settings, hands-on, touching machines, touching software, touching electronics, making things that work. So that's how we do. That's how we learn. That's what keeps us fresh. We like to say that our students solve open-ended problems using off-the-shelf technology to serve humanity. So that's what we do. That's what we do well. And we're looking forward, as I say, to you being here doing it with us. Thanks, Ryan.
No, thank you. Appreciate it. That's a good rundown. And yeah, like you said, the profession of engineering and lots of different pathways to get there. We're definitely one of those. So very cool. And want to highlight John, our technical director, is going to be putting up some different graphics on the screen as you watch tonight. And right now it's the Engineering Technology Difference webpage, which kind of gives some highlights about that different educational approach that we take for engineering technology as well. And Ken, thank you for mentioning the associated labs, because that's actually the next question that we have. Just how do our major courses built with those labs and lectures and group projects? And Anne, we'll start with you and just kind of give us an idea of your coursework and what that looks like with those labs that are associated.
Well, the interesting thing is I actually don't have any labs associated with my classes. However, knowing my students, if I don't give them something fun to do in class, we get ourselves into trouble. So we do a lot of, I have them do some review work, especially in the one course, because sometimes it's taken early and sometimes it's taken a little bit later. So, we do kind of fun things in groups where they're reviewing what viscosity truly is. We look a little more in depth at things like what's buoyancy and why do ships stay up. And then we actually take a look at some of the Coast Guard ships that actually have to rotate completely around in the water. And so we have fun with that kind of thing. When we have a normal semester and we're together, I have them do all kinds of things with tube bending because it actually mimics what happens in the real world. So we do that. I take them to the wastewater treatment plant and they get to see how everything's processed, but they also get to see the use of some very large equipment as well. And we do the same thing with the power course. I take them to the power plant. We go out and look at what's going on in, we have a couple of different places around here that are renewable energy farms and whatnot. And we go out and actually take a look at the equipment and get right up close and personal with it. And then usually we have an engineer or someone else from that facility who knows that equipment intimately. And then we have a nice discussion with them. So there's different things that I do. I also encourage my students because they're seniors usually. I really work with them closely to try to get them to think a little bit more about how they can use all that knowledge that they've gained over time. So we try to have them assimilate some of that and actually see how that works. So I try to give them more of a real life view of what it's going to be like when they go out to work. So hopefully that helps a little bit there.
That's great. That real world perspective is really important to have. Absolutely.
Mhm.
So April, you want to share a little bit about maybe some of your labs that you're involved with?
Sure, Ryan. So I have two classes, and they both has the labs with it. So what we usually do is we introduce the concept, and then one of the main things that we want to make sure is we're going to ask what does that mean, and students before they come to the lecture. They would actually read some stuff, and that's what I call pre-lecture. And then they'll have a quiz. We introduce the concept again in the lecture, and then we go into the lab and we say, okay, this is what you're going to see. And for example, in one of my embedded digital system class, is not just programming, it is including with the hardware. So we built a little crane, and it's a group project that they actually work together to make the crane going from one location to another, and they programmed everything on their own. So they have a lot of fun on that one. And so another class that we have a lot of math in that class. And so we would ask, what does that mean? When the math, this formula look like this, what does that mean? And then we talk about what we should be expecting in the lab. They go into the lab, and then we look at that from the formula to the real application, like looking at from a integration to looking at a light bulb turning on and glow, and they will know that, oh, in our classroom also has the dimmer switch. So we kind of tie everything together from theory to the lab and doing it on their own too.
All right, excellent. Thank you. And you mentioned kind of the specific kind of technology that you might be utilizing. And Jason, will turn to you with this one. Give us some examples. You kind of mentioned your internal combustion as well as the battery that you're working with. What are some other technology, equipment, software that you all are using in these lab situations?
Sure, thanks, Ryan. With the internal combustion engines course that I teach, again, it's a senior level course, and some of the lab activities that we do in that course rely heavily on some advanced technologies. For example, we use a state-of-the-art simulation software. It's called GT Suite, and what that is it's a computer program that allows students to configure an engine and run it digitally on the computer and make changes to it and put it in different types of vehicles. And they get to learn how the engine operates. And when you put it into a different vehicle, let's say you could put it into a regular vehicle or a hybrid vehicle, you can start to see how how the energy is utilized in each of the two types of vehicles. So using some advanced modeling and simulation software is one example. Another example in that engines class is we get out into the lab and we run experiments with actual engines. So we use a dynamometer test cell where students will get in the lab and we'll turn on an engine and let it run and run it through different sequences and have the students actually measure the engine performance and look at the different data. And again, with these labs, the whole objective is to get a better feel, better understanding of how the engines operate and relate that back to the concepts that they're learning in class. So those are two technologies that I use in my internal combustion engines class.
Cool. All right. Thank you very much. And Mark, you mentioned you're an MET professor, but then you also work a lot with instruments. So that's kind of a big disconnect. Where, is there connections between those, or differences that you could kind of get given some examples for us?
Sure. Before I was at Purdue, I worked in structural vibrations and automotive noise and vibration. So it's kind of a natural to pick up musical instruments. I've been doing it kind of as a hobby before I got here, and I really kind of was able to come out in the open and start the guitar lab here. So the kinds of things I was doing before here are still quite applicable. I was spent 10 years working as a engineer for the U.S. Air Force, a civilian engineer. We looked at vibrations in aircraft using analysis and test, and then 9 years in automotive where I was doing structural dynamics and acoustics. So there's almost a one-to-one correspondence of a lot of things I did there and then I'm doing here. So since this is all hands-on, when we go in the guitar lab for the stringed instrument design and manufacturing class, I divide the class up into teams, and each team designs and builds their own instrument. They build one for everybody in the team, and they start, literally from a clean sheet of paper. I make them brainstorm things on paper before we go to the solid modeling and then to the computer-aided manufacturing. We've got 2 CNC routers and a CNC laser in the lab, and I go through a lot of guitar factories, so I make sure that the things that we do in that class are representative of what they'll see in the guitar factories should they go there. And we've got 2 MET graduates working for Fender Guitars right now. One of them is a senior designer, and one of their wood technology guys.
That's awesome. That's really cool. Get that.
Yeah,
that
it is.
brand.
Yeah.
Nice. All right. I will kind of shift a little bit to Emmani. We've heard a lot from our faculty. Can you give us some examples of some of the projects that you've worked on in your labs so far that you've had?
Yes. So, April talked about a little bit about the embedded digital systems. I had French as a teacher too. He talked about his MET, what he does with MET. So I'll talk about an industrial controls lab that I have, an industrial robotics class that I have now. So in lecture, we talk about so if you don't know, industrial robots are the big robots that are in factories moving robots around the assembly process, or just the big frames, the big car frames around the process. So in this class, we're able to actually program one of those huge robots. It's a smaller version because it's inside the lab, but we're able to actually program the robot that would be actually on the line. It's the same technology, just in a smaller package. And I think that's really cool because that's actual industrial robotics that I'll actually see in the workplace. So yeah, like they were saying in lectures, we learn the material, the concepts, but in lab, we really do a lot of our learning, and it really cements in us through lab what was talked about in lecture, and that's where we really grow in labs.
Excellent. That's really cool to hear. Thanks for sharing that. Just want to point out real quick on our YouTube channel, in our Future Techies playlist, there's an actual lab tour of the different facilities and learning environments for the School of Engineering Technology. So youtube.com/techpurdue is where you can find that video. Take a look at kind of a virtual walkthrough tour that we put out there for you all to take a look at. All right. So turn it back to Ken just for a quick.
I was going to say,
Tamara, yeah.
Ryne, Brian, if I could just say something, we've been meeting with our students currently right now in terms of registration. And one of our favorite questions to ask is, what is your favorite class? We get the classes with the labs. We get all of the input. The students love what they do in the labs. It really, as Emmani said, cements what they are learning. They take it home. It is one of their favorite things. I just wanted to kind of put in there to re-emphasize the labs are really one of our strongest points, and you start with lab with your first year. So you're in lab day one until the end of your fourth year. So I just wanted to add that. I apologize.
No apology necessary. That's really good to hear. Gives us more feedback from the students. That's what we love. Excellent. Okay, thanks. Ken, I'm gonna turn back to you just to kind of get a little bit of information about if there's this like a senior capstone or a project, culmination project that students might work on, and if so, what can you have some examples of what students are working on right now?
Sure. So as part of the college's transformation, which is fairly well described on our website, but it probably means more to us as faculty than it does to students. But one of the things that we've done with all of our curricula in this college is that, especially in SOET, every student has a 2-semester capstone. So what does that mean? Well, the 2-semester part's pretty easy, right? It does last a full year. It's 6 credit. It is a very intensive design, build, test sequence. The capstone means, like Anne mentioned in her classes, it's designed to take everything you've learned in your previous 3 years and put it together and apply it in one project. Almost all of our capstone projects for the School of Engineering Technology come from industry. So we have faculty members, and we also have a staff person who meets regularly with local and nationwide companies to come up with projects that students can do as part of this course. And some of them are for local companies like Caterpillar here in town. Some of them are for companies that are on the West Coast, like Boeing. Again, one of the advantages of being at Purdue is that we do have this very large sphere of influence. We have students that are working on adjustable width wheelchairs. We have students that are working on optical vision systems to inspect car chassis, gears for drivetrains, and we have a very large aluminum casting facility nearby here in Indiana. And so there's a lot of visual and mechanical inspection of castings. So the students get to see real world parts. A lot of it is involved with how do we test these parts for high quality. Many of our students become process and product engineers. These projects are aimed at that. Some are in the healthcare industry. Many of them are, of course, in automotive and aerospace manufacturing. We also have projects that are aimed at agriculture. We have some going on irrigation systems. How do you verify that the seed density in the field is what you want it to be? So it's and the students get to pick. So we typically have we call it a book, if you want, with 50, 60, 70 projects in it, and the students get to vote on which project they want to work on. We try to assemble teams for people that want to do these projects. 4 or 5 students on a team, all different majors. So it's intense, but the students seem to get a lot of it. It's a great way to get hired because you are also working with an industry mentor as well for the full year. They have a good time. Many of them are also tied to internships, so it's a very immersive environment for our students.
No, that's really great, Ken. And a lot of different industries, a lot of different fields that are represented by what you just shared in those examples. And going back to what we heard earlier, the real world perspective, getting that immersion is really important. So Thanks for that. I think that's a good rundown. I'm going to turn it over to Tamara just to get kind of some of the academic advising, more the kind of the plan of study, the coursework that's involved. And you mentioned, day one you're in labs, the courses you're taking. What are some of those shared courses that our students in this department are taking, just to kind of get that sense of what they're doing overall? And then we have actually had a question that I already had ready to go, and that one of our viewers asked about what's the math requirement, the math level that our students go into in these majors as well.
Sure, Ryan, no problem. We get the math question a lot too, and we always encourage any incoming freshman, please have as much math as you possibly can have. It's not going to hurt you, and it can only help you. There is a calculus requirement for most of our majors, at least to have calculus 1, and most of them require both calc 1 and calc 2. We also have a statistical requirement for everybody, so I kind of group that with the math as well. We have about 9 to maybe 12 classes that are common to all of the different programs. Obviously, there's the Common Core, the English, the speech, the science, the math, things like that. But all of our students will take Tech 120, which is a great course. I always describe it to my students as an awesome project. It really is your first project course. You're going to be put on a team. The team is interdisciplinary across all majors in the Polytechnic, not just the School of Engineering Technology. You're given a real world problem. You have to brainstorm, do feasibility studies, and come up with a solution. So Tech 120 is a great, especially first semester class, first year class, and it really does teach you teamwork and working with a team. We are specific in the in the School of Engineering Technology, in that we teach our students Engineering Technology 180 and 181. And this is the foundations of engineering technology. And then 181 is the lab that's associated with it. And so it puts you into the lab experience, again, from day one, helping you understand those mechanical concepts, those electrical concepts that you need for your future labs. Helps you learn, how do I write a lab report that's going to be acceptable to my faculty in my sophomore, junior, senior level courses? What do I need to do? We're very big on the building blocks. What you learn at the beginning, you're still going to be using at the end, because again, it all ties together. We also, for many of our programs, have a programming requirement. So you're going to take some type of either a C programming, a visual programming, something along those lines. That's kind of common amongst all of the different majors in the School of Engineering Technology. And then, of course, different majors have specific classes that are applicable to them, but can be applied to different majors. So if you take, let's say you start off and you think you want to do mechanical engineering technology, we're going to put you into an MET 143, 144 materials and processes course. Okay, you take it and you decide, you know what, I really love the electrical stuff way more than I thought it was going to. No problem. That mechanical class can still be applied as a technical selective on your plan of study. We're going to maximize as many classes as we possibly can so that you can do as much as you want to do. Does that all make sense?
Well, for me it does, because I work here, but I think you explained it pretty well.
I was hoping so.
No, you're good. One question, just maybe if you give just a few examples of some of the courses in the industrial engineering technology and supply chain majors as well. We had a question from the chat. And then as a follow-up from there, how easy is it to switch between majors within the department itself?
Sorry, I had muted myself for a second there. No problem. Again, we get a lot of those questions too. So industrial engineering technology and supply chain, again, are also going to take those engineering technology 180, 181 classes. And I usually explain it, our degrees tend to be a little bit more technical. You're going to be working with technical people. You need to know how they think, how they function, and what do they know. Even at just a very general level, you kind of need to understand what are their thought processes. Trust me, I'm married to an engineer. The thought process can be a little different. So it is really good to kind of understand what that is. My background's a little bit more business than it is engineering. So the industrial engineering students and the supply chain students are going to be starting off, one of their first classes is going to be a foundations of organization. They're going to take lean manufacturing. They're going to take a bunch of different courses, a little bit more leaning heavily on the statistical side of things. How do companies take what they need for their products That's part of the supply chain as well. How do they get it from point A to point B? And that's a lot of what the industrial engineering does. So it's not just the business side of engineering, supply chain and industrial engineering, but it is an overall management, manufacturing, how does it get from A to B? So it is a great field. It is super exciting. We have a lot of students who like to do it, and we have a lot of companies. I do a lot of the communication for the School of Engineering Technology, and I'm constantly getting emails saying, hey, we really would like some of those supply chain students to apply for this internship that we've got. How do we get in touch with them? And I'm like, well, you talk to me and I will send out the information to them. And the same thing is true with the industrial engineering. So it's definitely a growing dynamic field that there's a lot of demand for. It's kind of sort of the lifeblood of most businesses. So supply chain and industrial is extremely important, and we're very grateful to have them underneath the umbrella of the School of Engineering Technology as well. And I apologize, Ryan, I know you asked me a follow-up question and now I've just kind of forgotten about it.
No, you're fine. Just about switching majors within the department.
No problem. Again, since our first semester is pretty basic, we try to get you into the English and try to get you either into the English requirement, the freshman composition, or the freshman speech selective. We'll usually get you started on your math. We're going to put you into ENGT 180, 181 if that works in your schedule. And we're going to try to get you into one of your possible prereq courses or one of the courses that's really tied to your major. So if you're industrial or supply chain, that is going to be maybe that organizational leadership course. If you are electrical, it's going to be this CNIT 105, Introduction to C Programming. If you are mechanical, we're going to put you into that materials and processes, and we have two of those. One of them works with the materials of plastics and laminates. The other one does metals and ceramics. For a mechanical student, you're going to take both. So it doesn't matter which one you take. If you're mechatronics, you have that requirement as well. And often for a lot of the mechanical and the mechatronics, there's a CGT, computer graphics, a CAD programming, 3D drawing requirement as well. So we're going to get you into some of those classes. Again, if you take something and you're like, you know what, I really thought that this was my love, this was my passion, but it's not, we can probably use that course as a technical selective. And most of our majors all have a technical selective or someplace that we can use it with. Obviously, making these decisions earlier is always better than later. We can we'll do our best, but the more you get involved in one major, it can still be done. And there are one or two minors. Let's say you start off electrical and you decide, okay, maybe electrical really isn't my cup of tea. There is an electrical engineering technology minor that we can still apply those courses to. And having a minor is never a bad thing. That help? Switching majors within the Polytechnic is usually not as difficult. If you go to a different school, let's say aviation or computer information, it's going to be a little bit different because again, they're going to have different requirements than we do. But we're going to work with you, and our goal is get you where you want to be as well. We think our majors are great, but we do understand, you're the one getting the degree. You're the one that has to actually complete it.
Okay, and then real quick, AP Calc BC with a 4 or 5 covers our math requirements. Yes?
Yes, it does. If you get a 4 or 5 on the Calc BC, you're going to come in with Math 165 and 166, and that will cover our first two, our two calculus requirements. You need a 5 on the physics exam. Usually to get any physics credit, you have to have the 5. I think the AP US History will take a 3, I think. I'm not 100% certain of that, definitely a 4 or 5. And again, we're going to utilize as much credit as we possibly can with what you bring in. So if we can use the class, we're going to use it.
Yeah, and then those conversations happen during our virtual STAR this summer when you meet with your advisor and talk about what credit you might have from AP, dual enrollment, IB, those types of things. So that's when that conversation will really happen and get that set up for you.
The other thing to remember, I was going to say, Ryan, if I can just also add in Project Lead the Way. We do utilize some of that credit as well. So if you have that, when we meet during virtual STAR, that is a great point to bring up and say, yes. I mean, we're going to try to ask you, but Lord help us, sometimes a question does get forgotten. If you've got Project Lead the Way, please, if you have a question about whether or not we can use any credit, mention it. We will tell you if we can use it or not.
Cool. Thank you very much. All right. We're going to turn it back. We got some questions about different research opportunities. And Ken, just as an overall, what are some of the research areas that the engineering technology school is working in? And then, if for my purposes, any of our faculty members, if you are involved in any research, just raise your hand so that later on I can call on you after Ken is done speaking.
So that's a really broad question because we have so many faculty members that are covering such a diverse area. And I think the ones we have here tonight, most of them do have undergraduate researchers working with them. But our robotics group has quite a few working for them. We have folks that are working with sensors, both vision sensors and other types of sensors that hire undergraduates for research. Gosh, you're stretching me on this one because again, so many of them are involved. Some students are able to get credit for doing this type of research. Most students end up at least getting projects out of this. We do have the capacity that if the research project is big enough, and that's nebulous, it can become their senior capstone. So we very highly value this, but of course it's very dependent on an individual faculty member to fit the students into their labs. Especially right now with added safety requirements, that is something we really watch on this safety of undergraduates in the research labs. But they're working on the biofuels, they're working in robotics. I don't know. I'll ask Jason next if he's got any working in his labs right now. Yes, it's a very active part of what we do. I'll just mention one more point really quick that I don't think has come up before yet in this discussion. This college and this school have master's programs and PhD programs. So the faculty are very actively involved in research at all times. So there's plenty going on here. Thanks.
Okay, I'll take it from there. Thank you, Ken. So again, I'm one of the faculty members here in SOET, and I've talked a little bit about the course I teach, which is the internal combustion engines course. But I also am engaged in a lot of research work. And a lot of the research work, as Ken mentioned, is done at the master's and PhD level. But I do also have undergraduates working with me in the lab. And our school and our college does a very broad, a very diverse research topics. I mean, the research spans lots of different disciplines. And even within my own lab, I do research in quite a broad range of disciplines. One project that I'm working on is studying airflow in an underground sewer tunnel system. The sponsor wants to know how the air flows in the sewer at certain times of the year, and will we get some unpleasant odors at an undesirable location at certain times in the year. In another project, we use a high power infrared lamp to heat up a huge die casting die. So it's a manufacturing industry related project, and we use a pretty advanced technology to try to accomplish that goal of heating up this large piece of metal. And then in another project, I work with lithium ion batteries, and I'm interested in the safety of those lithium ion batteries. And I'm sure everybody here is aware that those batteries are everywhere. They're in all of our devices around us. And even though their failure rates are very low, in the ones per millions or per 10 million, they still can fail. And when they do, they can catch fire. And in a small portable electronic, that might be not so big a deal. You just kind of throw it out, and hopefully you've got an escape route away from the device. But in a large system like a grid storage system or an electric vehicle where you have lots of batteries next to each other, having a failure in one can be a very bad thing for the rest of the system. So I have undergraduates, they can get involved in research in a number of different ways. The MET 392 is the one course number in mechanical engineering technology, where a student can essentially be a lab assistant, where I have a certain need, I just need somebody to come in and run some experiments in the lab. And yet we have all the COVID protocols in place if they need to come in person and do work in the lab. So they can come in and get some credit for doing that work. In another instance, students can enroll in an MET 499, which is an independent study course, where it's more of an open-ended problem. I would give the student kind of a general direction, and it's up to them to solve the problem, come up with a creative solution, and get it to work. And again, they can take that for credit. I know students can be hired, they can be paid for their work if they want to do some research work and there's no credit opportunity available, they might be able to get paid for that as like an hourly worker. And ultimately, it's great to be able to do some undergraduate research and then transition it into a master's or a PhD program. So students that do research and really like the experience of discovering and learning new things through research, when they transition into a master's or a PhD program, that can be a very good thing. So that's what I have there, Ken. Thanks.
All right, thanks, Jason. And I saw your hand go up earlier. I don't know if you had any more that you wanted to add to this.
Oh yeah, I do a whole different set of research actually. My specialty is engineering technology education. I like to look at what our students, how they think, act, do, engage, and what motivates them. I tend to have a lot of students, especially undergrads, who are really interested in seeing how that works, how we actually do the research, and then they like to do some of the statistical stuff. We've actually had word get out that I'm doing some of these things, and I've got statistics students clamoring to help us out because they want to see how to handle that data. They find it kind of interesting, and I've attracted a number of other students as well from different parts of the university, which is kind of fun because then they get to know each other and they work together. So it's a really kind of a cool environment for them. The other thing I do when we start talking a little bit more about grad students is I take the students who want to do something a little bit different, the ones who don't necessarily fit the mold. And I have a very broad background, having come from industry after nearly 30 years. Um, so working with them has been kind of interesting. We've done a lot of renewable energy things, from looking at one of the local wastewater treatment plants and trying to determine if it was economical to process some of the off gases that they have from the sewage as it degrades. And we've looked at, I do some work with another university. We looked at a student that thought he was going to get away with it, and he told me that he wanted to work on full-size autonomous vehicles. And I said, okay. So I arranged it, and he ended up getting his master's, and now he's working on his PhD. And we're actually doing some sensor system things because I also have a pretty big background in electrical engineering as well. So yeah, so there's a lot of things. I've got students right now who are looking at doing some things to learn how to teach people how to like STEM. I've got some who are interested in the community and how our students can actually interact with the community a little bit more and maybe attract them into some STEM areas that might be a lot more non-traditional. So very different from what Jason does, but nonetheless, our students are all interested in, and I think I can speak for Jason and me. We're getting both undergrad and grad students doing the same, and we get our undergrads who get so interested that they want to stay on. So, or even master's students who want to go on for their PhD. So we do have a good time. We learn a lot, and we're able to actually get some real life experiences, which is totally important to the whole learning process. So I just wanted to make sure I shared that part because it's a little bit different than what everyone else does.
No, it's still really good. Just different pathways for our students that are available for them. That's great. So I want to just kind of get to some topics about student support and how faculty are involved with that. And April, I think you ran some some like tutoring labs and extra open labs for our students this past year. Can you talk a little bit about that? Just with students who might have some questions or struggles in their courses, how do we help support them here?
Sure, Ryan. So yes, what I find is most of the students actually work at nights, and they do their homework at night, and we're available during the daytime. And with COVID, we have to be available virtually. And so actually it started about a couple years ago that there is a tutoring session that helps students helping students. And I basically got involved, and I'm at home virtually, and then they're actually open lab. They're over in a lab, project labs, and they can call me using Teams. And I actually have couple student tutors over there in person, and they basically, if they cannot answer the questions, they take the tablet over to them, and then I can talk with them face to face virtually, and that helps out the students a lot, I feel like. And that's also another thing is students come into our program, and they learn from each other, and that's what we also want to encourage is students learning from each other, and they build their own friendships, and I'm just there to help out and answering those that they cannot answer themselves, and that's really helpful for most of the students. And we're also, faculties will go to the open labs and will help out during our break time, and see if there's anything else that not only just for our own classes, if there's other classes that we can help out, we will.
No, it's really cool the faculty get involved with those kind of extra sessions like that. We also have in the Polytechnic what's called BEST, or Building Excellence for Students in Technology, where we have students who have completed courses serve as academic coaches. So when you're taking that class, you can meet with them one-on-one to get that extra support. Some extra math and physics tutoring that's going on as well, that's sponsored by some of our faculty here. So yeah, some good support overall, as well as academic success center, supplemental instruction that's available across the university. A lot of ways to get that academic support that you might need potentially. Turn it back to Tamara real quick to just kind of get a sense of our professional work experience or internship requirement. I think that's something that the Polytechnic has been really pushing the last few years as we've gone through this transformation. What does that look like for a lot of our engineering technology students? Then we'll turn it over to Emmani to hear about some of her experiences that she's had.
Sure thing, no problem. The professional experience often for many students can be met simply by an internship. They have a summer opportunity, they decide to go ahead, they want to work for a company, they want to get a feel for what the working in their major might be like, so they do an internship. We also have many students participate in the co-op program. The co-ops will also most definitely satisfy that internship requirement. If for whatever reason, and we do have students, some of our military students or just some of our students based upon their own personal needs, requirements, whatever, are not able to maybe participate in an internship over the summer, that internship requirement can also be met by your capstone. So we've got you covered. We're going to take care of that. But again, it's a great opportunity. If you have the internship experience, for example, in the MET major, this only works in the MET major, you have the opportunity to take maybe some other capstone courses up to 6 hours worth, 2 classes, instead of taking the year-long industry-sponsored capstone. MET is the only requirement, or is the only major that does allow this variation if you have an internship. Otherwise, all of our students will do that capstone, which again, as Ryne said earlier, or Ken said earlier, it's a great experience. It is an awesome experience. Also, a lot of students find their jobs and find permanent offers from their capstone experiences. It really is usually a really great experience for them.
All right, thanks. And then Emmani, I know you've had, I think, an internship recently. You want to share a little bit about that experience for us?
Yes. So actually, I'm a sophomore, so freshman year, I actually took my chance and went to the industrial roundtable, had some faculty fix up my resume, and I went dressed nice, and actually scored an internship back in my hometown. So I was able to stay with my parents, save money, but also get an amazing internship. So in this internship, they're industrial system integrators, and basically what they do, to, you know, generalize it, is that they create automated solutions for different manufacturers. So if a manufacturer, if their assembly line is bottlenecking and parts are slowing down, my company will come in and make a solution for them. Oftentimes they integrate these huge robots to help them accomplish those tasks or do jobs that people can't do. So I was able to work with control panels, which is another class that you take. And so that class was, it helped me through that class, this internship, and the industrial robotics class that I'm in. I worked with that over the summer, so that class is going pretty well. So I've worked with a little bit of AutoCAD, but it really, Purdue helps you to get internships. It's not hard to get them here. They help you connect with people. It's so many opportunities to get internships, and the internships that you gain through Purdue are amazing internships, and you really learn so much.
All right.
Ryne, if I can piggyback on what Emmani was saying, we have several career fairs. In particular, we have the Polytechnic Career Fair in February, which is a great opportunity to participate in, hear about some internships, go to a company you're interested in, find out what they're looking for. You never know. It can be a great experience for you. There are career fairs throughout the year. As Emmani said, the Industrial Roundtable in the fall, Polytechnic in the spring. There's a just in time, there's the co-op days. Even if you don't do a co-op, they do have internships there as well as full-time positions. Lots of different opportunities. And of course, you have to mention the Center for Career Opportunities, which is definitely there to help you write that resume, help you with the cover letters. There are a lot of resources out here for you as long as you're willing to take advantage of them and utilize them. And I will say it's also reflected in Purdue's placement rate. Most of our graduates all have jobs, which is kind of a nice bragging point.
Yes, it is. I'd say so. And you even said yourself earlier that you get contacted from companies that you then share information out to all the students about. And Marco, I'll turn to you first and kind of run through our different faculty, because I know a lot of you have had some industry experience, and maybe share a little bit about what that was. And I think, Mark, you did a little bit earlier, but how do those connections still stay fresh so that you can maybe push some students in those different directions that we have here?
Okay, I came here from automotive, and a lot of our students go into automotive. The industry connections that are the hottest for me right now are in the guitar industry. And so one of the funny things about COVID is that everybody's home now, and I guess everybody who's ever even thought about wanting to play a guitar has ordered one. And so the companies that I'm working with are all working just absolutely flat out. They've got more orders than they know what to do with. And so as they're staffing up, I get, I get notice of when they're hiring, and I routinely send students that I think are particularly good. It's one of the nice things is that I hire students to help me run the guitar lab. Well, we did before the building got torn down. The guitar lab was in the building right next to Kanoy Hall, where my office is, and it's been torn down to put up just this beautiful new 5-story building. The guitar lab's in temporary space now for another year or so. And the new guitar lab is going in on, I think it's the 4th floor of the new building, and it's going to be just the nicest thing ever. When that happens, it's local again. I'll be hiring my students to help run that, and those students have and will do projects for guitar companies I work with, and so that they'll be well placed. If that's the direction they want to go, they'll be well placed to do that.
Oh, that's really good. Again, I think the experiences that our students get here in the labs and what they learn of how it's going to relate really does impact and help them in that future step. April, yeah, how about yourself? Any industry connections that you kind of help share out with your students?
Oh yeah, so I was actually I was the engineering technologies graduates many years ago, and so my first job was an integrator, just like what Emmani was talking about. I actually built jail automation systems in there, and so putting together all the kinds of systems together. And then I was an engineering manager and research and research and development manager for a company. So a lot of project management, and when I was an engineering manager, we have to look through a lot of electronics, and also schematics and codes and all that. And so I bring all of that into the classroom, and all the different things that we integrate to, that's all in the classes that we teach.
All right, great. And then what about you, Jason? How about your connections that would help you with your students?
Sure. So like Mark, before I got to Purdue, I was a civilian engineer, not at an Air Force facility, but at a Navy facility. So now that I'm here at Purdue, I'm working quite closely with, there's a Navy base in South Central Indiana. Believe it or not, if you're from the area, you know, but if you're not, you may not know there's a Navy base in the middle of Indiana. And I work quite closely with them on some of my research projects, particularly related to lithium-ion batteries. And I have an undergraduate student working with me right now who is designing a tool to dissect lithium-ion batteries so that we can analyze them and the materials inside. So we're going to take the tool down to the Navy base, and they are going to use that tool to open some live battery cells in their test facilities. So I have a close connection with the Navy and some other government agencies related to lithium-ion batteries and battery safety. Um, and I have some other industry contacts related to other research projects and related to teaching. So I'm sure my other colleagues here on the call probably do this as well, but I'll have folks come in from industry to give a guest lecture. I've had folks from Cummins or GM come in and talk to my students in the engines class. And it's a great way for students to kind of see what type of career path could be waiting for them at those places, and a great way to hand your resume directly to an industry representative. And another case, I actually took my engines class out to Caterpillar, and we took a plant tour of their engine assembly plant, which was pretty neat. Another great way to interact and hand your resume directly to somebody in industry.
Ryan, can I add one more thing here?
Yeah, absolutely.
Yeah, one of the companies that's historically really liked our students is a company called ArcelorMittal. They're a specialty steel manufacturer just a little north of here up on the lake in Gary. And they're interested enough in MET students that they've actually been donating to our department. And so that they're actually sponsoring my undergraduate statics class. So every year I get something like $3,000 to buy new lab equipment for my statics class directly from ArcelorMittal, and they're doing that because they want to stay in the forefront. They want to make sure the students know who they are, so when it's job time, that they'll know to call ArcelorMittal or go contact them. And that's, everybody says, oh, people are our most important resource. Well, okay, are you willing to pay for it? Well, they are. I mean, they're putting their money where their mouth is, and that means a lot. They wouldn't do that if they didn't think it was valuable.
Yeah, that's a great point. And actually, a couple of years ago, one of my ambassadors in the EET major, he interned at that location for the summer. So yeah, they definitely keep that connection going. And Anne, I know you shared a little bit about your industry connections. Any more that you want to add before we move on?
Yeah, I think one of the things I want to stress is professional societies. That's one that I think our students need to become even more involved in than they are now. I'm a member of the Society of Women Engineers and have been for a long time, goes way back. And just those connections that I have, the student will say, hey, I want to go work for so-and-so, and I'll just dial somebody up I know and say, hey, what do you think? And they get really excited about it because they're starting to see a lot more students coming out of Purdue, and they think it's really cool. So the other thing I've had too is a lot of our students actually leave, go to jobs, and their employer liked them so much, they ask them if they can get more like them. And so they come to me and say, hey, do you know any graduating seniors? Well, of course I do, because I have 2 classes full of them. And then I go ahead and I recommend, and right now we're in the middle of 2, I have 2 students former students who came back and are now looking for students to hire. So always lots of opportunities there, and just networking is huge. And so those are a lot of the things that we do.
No, that's really good. And actually that leads into a next question for Emmani. Is what kind of organizations, student clubs, and then the like are you involved in here on campus?
Wow, love this question. I actually have a list because I forget. But currently, what's what I'm doing this video call through is I am a Purdue Polytechnic student ambassador. I'm also the vice president of the Minority Technology Association in the Polytechnic, where we aim to create a safe space for the minorities here. I'm also a FRI organizer, so that's female recruitment and retention initiative. So I work with Nancy Ditton to host events to get women in the Polytechnic, and not only get them here, but to keep them here, to create a community for them as well. I am a member of Women in Technology, just a community of women here in the technology, and also like a Boiler Tracks member. Boiler Tracks is basically a minority recruitment club where we aim to get minorities like just to the Purdue overall. So I'm in a lot of like recruitment and type of events. So I do a lot of these videos. You've probably seen me before.
That's awesome. Very cool. Well, I think that was kind of the last topic-based question. I always like to end these broadcasts that we do, just kind of going through everyone and kind of sharing any advice that you can give to our incoming students about how to be successful in the Polytechnic at Purdue in this department. Let's see here. Anne, we'll start with you. What kind of advice might you give to our students here?
Don't be afraid. Try whatever you think you can handle. And if you don't think you can handle it, ask, because we're all here to help you. I've got students who totally freak out, and I'm like, just relax. And we get them through. And it's amazing. I've had undergrads I've helped and graduate students I've helped, and it's rewarding for us. But the best part is to see that we have students who sometimes don't think they have the skills or the ability to do something, and then they see at the end they actually do. And I think most of us are here to make sure that we actually make sure that happens. So we're a little bit of a different, we're different in that way. We want to make sure everybody's doing well.
Yeah, I think that's a good one. Just ask, get involved, and ask how you can get involved. Very cool. All right, next up, April.
Thanks, Ryan. I think tagging on to Anne's is that you're not alone, and we are here to help you. But one of the things is don't be afraid to fail too. I mean, you will fail at one point or another. Is how you pick back up and face the challenges. That's what builds you.
No, I think that's good to keep in mind, especially going from high school to college. It's a different experience and more than likely going to be tougher. So yeah, keep that in mind. I think that's a good thing to know as you move forward. Tamara.
Again, you're probably going to hear a lot of the same phrases. Get involved. Don't be afraid to ask questions. But I would also say, too, don't forget to remember your advisor. Your advisor's there to help. We get a lot of questions every day, and they're not always all related to academics, and that's great. We are here to help. If we don't know the answer, you've got a financial aid question. If we can answer, we will, usually financial aid, things like that. We will tend to direct you to financial aid, but you know what? We're going to help you find financial aid. So do remember your advisor is always there to help. You have a problem with a class, you're not getting concepts, talk to us. We are up on most of the free tutoring and help sessions and anything that we can do. So again, just remember, you'll hear this a lot. We're here to help. Come and talk to us.
Yeah, and especially as you go into Virtual Star, that's your first conversation really is with that advisor. So setting that relationship up really at the beginning is really important. Thanks. Emmani, as a student, what do you have for us so far in your experience here?
I will say time management will be your best friend. It's equally important to stay on top of your studies, but to also have a social life. College is a time to have fun, so make sure you have fun, but also keep your studies ahead. Don't be afraid to say no. If you know you have work to do, be like, no, I can't right now. I have stuff to do. But what about the weekend? You know what I'm saying? So Time management is important. School comes first, but make sure you have a social life as well, whether that's just you personally going to work out or grabbing lunch with friends or something. Take a break, and you need time for your mental state.
With the phrase, the work-life balance, as we all try to do that. All right, I think that's good to know. Thank you. Jason, yourself, what do you have?
I mean, it's pretty hard to follow all the great advice. I mean, I think Purdue is such a great place with so many opportunities. You're going to meet so many new people in all kinds of different areas. First, yeah, definitely, like Emmani said, remember time management. But if you have any extra, I would encourage you to explore all of the different things that Purdue has to offer, because time is going to fly by, and you don't want to leave something on the table if possible. But have fun at the same time.
Yeah, for sure. College is a fun time. That's for sure. All right, and then Ken.
So mine's going to be a little bit different because I have a somewhat different job here. Most of us, and I think you probably heard that from everybody that spoke tonight, we love what we do. Most of the faculty you talked to tonight have come from industry. We came here because we both love our disciplines, but we love what we do. And part of what we do is you. And so most of us are very free to express the fact that we love our students, we love our classes, and we will take care of you. I think, Anne started off with that. We will take care of you, so go forward without fear.
All right, excellent. Thank you, Ken. And last but not least, Mark.
There we go. Now I got it. I'll differ a little bit from the group. Our students come to engineering technology a lot of times because they just want to make stuff. If that's what you want, boy, this is the place to be. Well, Purdue has a secret weapon. We have something called the Bechtel Center. An industrialist named Steve Bechtel funded this, and it's a family connection there because my dad retired from Bechtel Construction. When I was a kid, we jokingly referred to him in our house as Uncle Steve, never having actually met him, of course. But the Bechtel Center is full of very nice, well-maintained, brand new manufacturing equipment. CNC lasers, water jets, CNC mills, CNC router or lathes, and it's all available to the students. In fact, it's more than that. It's not available to the faculty. I can't use it. It's there only for the students. Well, if something like that had existed 8,000 years ago when I was in college, you'd have had to burn me out of there. I never would have left. And it's there. It's just go. You have to go do a little bit of training to make sure you're not going to break the equipment or hurt yourself. And after that, go build anything you want. They don't care. Wow, what an attraction. How could you not want that? So that's the big one for me anyway. If I was here and I was 18 or 20, I'd move in, man. I would be like sleeping under the tables. The other one, this is real nuts and bolts stuff. If you come here or if you go to another school, go to class and do your homework. It's amazing how all of us as professors know that the people who go to class and do their homework, that's the secret sauce. That's the magic. Those people always do better on average than the people who don't. That's it.
Yeah, it sounds so basic, but yeah, it really does work. I think that's a good thing to end on. Very nice. So yeah, that does wrap up our discussion tonight. So I want to thank everyone at home for watching and submitting your questions. There were a lot of good ones. A special thank you to all of our panelists for the great discussion and the insight tonight, as well as John O'Malley, our technical director behind the scenes, putting up great graphics and make sure this broadcast was going well. As I mentioned before, please feel free to email us at techrecruit@purdue.edu if you have any additional questions that you didn't get answered, or things you want to think about or know about later on, whether it's about SOET, Polytechnic, or Purdue overall. Just a quick reminder for our admitted students, the deadline to accept your offer of admission is May 1st. So we will actually have another live Q&A broadcast for all of our students that are admitted to every major here in the Polytechnic on April 13th. You can find that broadcast or watch the replay of tonight's broadcast if you didn't catch everything by going to polytechnic.purdue.edu/live. So thank you all again. Thank you again to our panelists. Hope you have a great rest of your night, and boiler up.